Hello, welcome to Econometrics Melody. In this tutorial, we'll learn how to create variables using egen command. So egen command is an extended command, the generate command. So let's begin. This is a Stata interface. You can activate your do files directly from here or by pressing Control 9 with this main Stata interface active. Let me arrange this a little bit. Then after for data editor again, you can press Control 8 with Stata interface active. Thank you. Let us clear everything and I'll set our observations to 24 and let us generate a sequence. Generate a equals to sequence. So this is also one of the egen function sequence. It helps us bring a sequence of numbers from to 10 and in the block of, let's say, 2. So every number will be repeated this block number of times before the occurring of other number. Let's see it. There we go. Now let us keep some room for missing numbers. So let us say replace a equals to dot in 22, 21 to 22. And again, replace a equals to 0 and 23 to 24. So we want to see whether the missing value and 0 will have any special effect or not. Then after we need a couple of more variables. Another variable b equals to, let us take are you uniform into 10. Control D and let us copy this. Let's take C. Okay, we're all set now. The first egen function that we're going to talk is any. Let's see what is anycount all about. So egen d equals to anycount, the variables a, b, c, and the value we are practicing actually. Let's say I need to give this value to 1, 0, 1, and 5, and 20, any number that you like, and 19. Okay, so what does this do? So this, the variable d, actually it counts the number of variables that we have supplied, number of variables that contains these values. Okay, so in the first observation, if you see, there is only one variable that contains one of these values, or at least one of these values. So 1, so this is due to variable a. In this second observation, if you see, we have two variables containing at least one of these values that we have asked for. So what are those values? 0, 1, 5, 23, 19. Let us see. 0, 1, 5, 23, 19. So 1, 5. It is due to a and b, variable a and b. So this is all about this function. So sometimes you may deal with a situation that you don't need the observation that does not contain this value. So how will you do? And you want to write keep it this not equal to 0. Then you go on making analysis of this variables only. So depending on your situation and requirement. So this is about anymatch. The other function is about it is anymatch value something. Okay, so let us create another variable e with anymatch this, and let us see what happens. So this is an indicator variable. Wherever this condition is satisfied, we get the value 1. E has the value 1. Whenever it's false, the value is 0. So in the d and e are the variable d and e are same. So the non-zero values in d will have 1 in e, and the zeros in d will have 0 in e. So this is very simple. Now let us, so this is about any value and not var list, we need to supply the var name, value is integer numbers. Okay, so before this we need to drop d and e due to our space limitation, and let's generate a variable called d anymatch. It is any value, so only a var name. Let us generate a variable d that has a value of a and only the selected value. Okay, so you see, wherever we wanted from a, we wanted those observations that have value 1, this value. So we have 1, we have 5 and 0. Okay, that's it. So you could have specified the number list in this format as well, 0, 1, and let's say 5 to 7, and then maybe 23, 32, whatever. So we have this d contains 1, 5, 6, 7, 23, and we don't have 23, and 0. So you can write if they is not equal to dot. You see, now you can make an analysis based on the value. First, now let us remove this, we don't need this. Let us run this once again, and let us drop variable d. Now the another is cut, and actually either you can use it so many breakpoints separated by comma or without comma, or you can use group, right? How many groups you want, maybe some number of groups, and then you can type icodes, means do this category variable will have code or level. Now let us drop there and stick. So we need to cut this. Let's see what happens. So the first breakpoint is 2. So anything that is less than 2, that is excluded. So from 2 to the second breakpoint is 5. So 1 less than 5. So 2 to 4, that is labeled as 2, and 5 to 7, 1 less than this breakpoint. So 5 to 7 is termed as 5. Then after 8 to 11 is termed as 8, and this is how the cut function of the egen command works. So this is clear. So this is one way, and based on your requirement, you could have done this as well. Let us create another variable. This is very important function called cut. Control, let me write variable e and cut. Let's not use, let us not provide the breakpoints, and let Stata decide. We need only 4 groups, right? So this is the 4 groups. So what is the difference if you label it? In the first case, you see the label will be generated. If you require I codes, actually that is the codes, this number will not be displayed. Actually Stata will provide its own code 1 2 3 0, starting from 0. You see, if we provide this group, then I code is not required. You can provide a label. Like cut function of egen command will help you create the categorical variables. So let us also label this, not I codes. So let us label this. So tabulate d, tabulate a, and you see what happens. So when you tabulate d, we have provided this cut points 2, 5, 8, 12, 2, 5, 8, and when we tabulate e, the frequencies are nearly evenly distributed. This is the coincidence, right? If you write 2, 4, and you see what happens, these are not even. You can see what the level is. You see 0 1 2 3 4, these are the levels for variable e, and 2 4 8 12, these are the levels for variable d. In the data editor also you will see the same thing. Once they are labeled, the color changes to the other functions. Let's count. It counts the non-missing numbers, right? So it counts the non-missing number. Let's drop now d and a. Is in d happening. D equals to count. Let's say a, because there are two missing numbers, right? So 22, because these two are missing. Or you could even write a divided by d, an expression plus minus square root of this. Does this work as q or t square root of this? You see, it does not matter a lot. So this difference is also very, very important. It also creates an indicator variable based on conditions that we provide. Let us drop d and we egen equals to difference of ABC. So we need to drop and run this. You see? So none of the observations are exactly equal. All three. So if you want to write difference between A, B, and you see what happens. A and B are also. This is really very interesting. None of the observations are exactly equal. So B is a random variable, right? Let's try this. B keeps on changing. Do we get 0 here? You see, we got 0 in this 15th observation. And we say A and B, they are equal. So 0 means they are equal. The value of A and B are equal. So it can be C, control D, and you see, do we get any 0? No. Okay, so you see, the observation number 8, and both two of them are equal, but it's still A equals to B equals to C. This is the condition. And if this is false, I mean they are different. Okay. There is another function called fill, egen function. It's fill. This is also very, very interesting one. So let us drop D to this. Then after you write egen d equals to fill, and you need to supply any two numbers in their increasing order, right? Maybe, or the number list, how you present number list. And if you write 2 and 3, it begins with 2 and increases, difference is 1. If you write 2 3 5 2 and 5, the difference is 3, and 12, difference is 7, and maybe 30, or even if 12 and then 19, you see what happens. So this will follow this pattern. And if you in fact require only a serial number from 1 to, let's say, the difference with 1, and see all the serial numbers, you can write it in this way. Okay, let's interquartile range. IQR is egen. Did we drop D? Let's drop D real quick. So egen D equals to IQR interquartile range of which variable do you want to place? Let's say C. What happens? So this is the interquartile range, and A is the variable, C is the random. Let's see. Let's decontrol D so many times it keeps on changing. This is the interquartile range. After interquartile range is median absolute deviation. So it's MAD, median absolute deviation, and the expressions that you have provide, right? So let us drop D and let us say we want to generate D, and this time we're going to try some other expression, right? Not only a single variable. Let's say we want A plus B minus C. What happens? Mean absolute deviation. It's 3.5. Keeps on changing. So after mean absolute deviation, we have max of the expression. Get a bit lazy this time. Save our time. Let us drop D and egen D. Let's take max of this variable. 14 keeps on changing. Okay, after max we have so mean deviation of the expression, and let us copy this once again. Control C, Control V. So mdev, and you see deviation. You can find the deviation of a single or some expression of the variables. This is also very simple. And then mean. This is also very simple, guys. This is also very simple. So you write mean here, and then it's drop D, and mean of A or this expression. A into A minus, let's say B. B into C. So we'll get some values, don't worry for that. After that, median. Same is the case with median. Just write. Okay, let's learn one thing now. Control V up is to find this, and you want to find mean. Control H is to replace. You want to find mean and replace with median. Okay, only on this selection. So replace all, and there we go. And let's run Control D. So there is the median, right? So in the case, Control C. Let us mean of the expression. Control V is the past. We have concluded up to median. Now let us again Control H. Now we need to find median, and median, and we go for finding mean of the expression and replace all in selection and see the changes. Replace all, right? Let's Control D. This is the minimum, right? Because we have A square minus BC. It's 48. We don't need to worry for that. These are very intuitive control, but still we're practicing. Don't get bored. So the next is very, very important. Percentage, PC. Okay. Control H, find and replace. It's Control find mean, and then replace with PC. So replace all. You see what happened? Ah ha ha ha. So replace all without selection. We did it damage. PC. So this mean and mean. Okay. So it did damage a lot. No, it has not made any. Only these two observation times. So percentage drop D equals to percentage. Okay. So if you run this, you will get the percentage, and if you add A square minus BC, and what happens if you add this all? Let us summarize and total, right? We need the sum of D. What happens? Okay, let's get the cumulative sum of D. Then A equals to sum of D. You see, you'll get a cumulative sum. I'm a running sum. It's 100. It's 100. This is the percentage. So let us take a simple. We wrote this A square minus B square. This will be more clear if I delete this term, and if I write Control D. You see? If A were the frequency, then this would be the cumulative frequency. So rather than writing the numbers, I mean, you could write in proportion also. So for that, you need to write an option PROP, proportion. And you do this. You'll get 1. Now let us solve percentile. And I think this is also new. Generate is sum. This is also very new to us. This will create a running sum, not sum. Let's go to percentile, tail of it. So let us drop D and E. We don't need this now. And let us egen. Let's say D equals to pctile, percentile. an expression of, let us take what is the expression of a and which percentile do you want to. If you don't provide this, by default it will take the 50th percentile, that is the median. So which percentile do you want to take? So let's say you want to take 20th percentile. So if you write 20, let us say whether it is the 20th percentile. And if you want to write 50th percentile, what is the median? So it's 5 is the median. Okay, that's fine. And you can, in place of a variable, you can use some expressions. So let's say what happens if you add a and two random variables b plus c, and you find the median of that. It's 15. Okay. Maybe what would be the first quartile? All right. Okay, it's 10. This also comes handy, guys. This is very. After this, let us take a very random number. Now, another important thing we're going to learn, and that is about the rank. So this is about the rank, and I think it allows your expression as well. Rank. So it allows your expression, and then field, F for field, and then you can use either track. Track is, if the highest is to be ranked first one, then you need to provide this option field, or if the lowest is to provide it the rank first rank, then you can use track option, and another is unique option. Let us rank this first. Okay, rank of b, and then the highest should be first. Okay, control D. Variable e not found, job e. Okay, control D. Okay, variable is not allowed in. Variable is not allowed. It should be this. One simple mistake will trouble us. Let's see what happens. Now whether we are, let us not, for comparison, let's substitute b with d and see what happens, and then let us sort in terms of d. Okay, and you see what happens. So the highest, once you sort d, you'll know the highest value is given the first rank, and so on. So if we reverse this, let us gen e and we use the rank of c. Okay, but we use not field, but we use track. Then what happens? And let us sort d again. So just reverse. You see d and e, they are just a reverse of one another. So this is the difference between field and track. This is also one of the very important. After rank, it's row first. This deals with the missing numbers, right? And you will have to provide the var list. So it will provide the non-missing values, first non-missing values after the var list. So you're right, we need to drop d and e, we don't need this, and though there are not many missing numbers, only observation 2 and 6, they have some missing numbers. So let's see what happens. Observation 2 and 6 is and d equals to row first, right, and supply the var list a, b, and c. What happens? You see, these are the missing numbers. So what is the first observation up just after the missing number in this var list ABC? It's 2, so its value is 2. So what is the first 7? Its value is 7. Otherwise, it is all are same. So in place of row first, control H, First we need to replace it by rowlast, and don't forget to just replace this selection and replace all. You see it was row first, now it turned to row last. So we only drop till and replace c equals to let's say dot in 5 to 9, and let us run this. What happens to the so rowlast is the last non-missing number in this pair list ABC. So the last non-missing number is 6, last non-missing number is 3 out of this ABC from this. So let us go to rowmax. By the name it's very clear. So rowmax, drop D, okay, fine, this is fine, and D equals to rowmax. And you see what happens. What is the maximum of this row is 10, maximum of this row is 10, maximum of this row is 9. This is very simple. Rowmax, rowmean, 1, control C, control V bill. Now let us find what is the rowmax. Write down with rowmax. Now rowmean, control H. Let us find a rowmax, and we want to replace it with rowmean. Make sure that you select replace all in selection, otherwise it will just destroy everything that you have in its data, right? If the number matches. Okay, replace all but in selection. It's rowmean. Let's see what happens. Control D. So 10, 0, 13, I'll divide by 3 is 4.3, that's fine. But this is, here is one missing number. So rowmean is the mean of this two. 9 plus 5 is 14, 14 half is 7. So see how it treats missing number. So 6 plus 2 is 8, 8 plus 4, okay, fine. I hope you got this. So rowmean is also very, dear friends, don't get bored, we are practicing. After rowmean we have a rowmedian. Let's do this by control F. Let's find a rowmean tab, and then we say rowmedian, replace all in selection, and you see what happens. Rowmean, rowmedian, okay. Let us control D. So this is the rowmedian. So you might be confused. Median is middle, the variable B is the middle. No, you'll have to arrange it either in ascending or descending order. So 0, 3, 10, 3, and 5 and 9. So what is the median? Just average of it. Times 5 is 14. Okay. Here 6 and 2. So 2 and 6. What is the in between 6 and 2? That just equally divides. Equidistant from 2 and 6. That's 4. So this is also very simple, guys. Now rowmean. But the name is very clear. Control V. So we need to search a rowmedian this time, and we place it by rowmin. Okay, replace all in selection. Okay, replace all. So rowmin. Now let's execute it. So minimum of this is 0, this is ignored 5. This is also very simple. After rowmin we need a row missing. Okay, this deals with missing, and another function will deal with not missing. Control V. These are very useful. Okay, after rowmin we require row missing. Control H, and previously we had dealt with the rowmin. Now we need to have a rowmiss, right? Rowmiss. Then after all, replace all in selection and replace all. So rowmiss. Control D. See, in the second observation, 1 missing, because in here 1 missing, 1 missing, and 0. So it gives you the number of missing observations. Rowmin. Let me select this. Control V. Now rowmiss. It's none. Okay, let's see what happens. In fourth observation, we have two non-missing. So this helps you. These two functions, rowmiss and rownonmiss, will help you find out the number of missing observations in each row of any variables that you provide. Okay. Now let's take a row percentile. Control H, type rownonmiss, type row percentile, pctile, okay. In selection, guys, in selection, replace all in selection, row percentile, and let's see what happens. So in percentile, we have not supplied which percentile are we talking about. So by default, it took the mean. So what is the mean of this? 6. What is the mean of this? 1. 9, sorry, 9. What is the mean of this? 6, 9. What is the mean of these two? 8. Okay. So if let's say we want the 25th percentile, what will this display? Okay. And what if we write 75? Okay, I'll do 40th percentile. Okay, this is fine. As we have less number of observations, so the percentile are quite stacked, right? So this is a very simple row percentile. So after row percentile, let's find a row standard deviation. Control V. After row percentile, let's find a row standard deviation. It's row percentile. Control H. Find a row pctile, and let's find a row standard deviation. Again, the observation may be very less for this, but it's still, for the sake of practice, replace all row st. And if we execute this, what happens? Option P is not allowed. Okay, Control D. You see, row standard deviation. It's very simple. After row standard deviation, let's find a row total. Control C, Control V. Let us select this. Control H, row SD, and let us find row total. Do you see the change? It was row SD, now it's row total. Okay, this is the total, this is the sum, right? This is very useful. There may be cases when you need to find the sum of the variables, right, for observations. So this will help you find this. Now we have found the row total as well. Now let us find what is the standard deviation of any kind of expression. So what is the difference? Control V. Okay, standard deviation of the expression, of any expression. Okay, replace C. Okay, egen equals to standard deviation of an expression, not ABC, A plus B minus C. First, let us try to find standard deviation. So this finds the standard deviation of A, and then this is some constant value, right? So A plus B square. What happens? Okay, this is the standard deviation. Okay, an expression, this is fine. And then after standard deviation, you can fill this number with a skewness and q-assist also, not SD. So Control H, find ASD, then after SKEW, and replace all in selection. Okay, replace all, and then you just Control D. You'll find the skewness, invalid name. So skewness of variable. Okay, Control D. Skewness. So let's find a day. Okay, this is for single variable, not expression. Skewness is for single var name, and you can provide if in depending on your requirement. Okay, then after, okay, standardized expression. When we subtract the mean and divide by standard deviation, that will be your standardized value, right? So let us control H. We found the skew, and then we need to write std, standardized value, and replace all. Okay, enter. So let me select this. Replace all in selection. Before we commit any mistake, we need to be very alert. So what is happening? Okay, control H. This is skew, find skew, and then we replace it by std. Replace all in selection. Replace all. Okay. Standardize of var name. Okay, or you can use any expression you like. So std of b, control D. You don't believe how this is a standardized, how D is an standardized value. Okay, let's see. Doubting sometime, in most of the time, it's also good. So let me just press this and again run this command once more. You see, standard deviation is 1 and mean is this to the power minus, it's 0. So we get a standardized value after subtracting of any random variable, right? You need to subtract its mean and then divide by its standard value. This is the standardized value. So if you want a standardized value of, let's say, d equals to a into b, let me arrange this. And if you want a standardized value of a into b and c, let's say a into b minus c. Instead, I will not get anyway, right? It provides its standardized value. And if you can summarize d, you should get the same result. The variance is 1. Did we not summarize d? Okay. Yes. You see, mean minus this to the power minus. Oh my god, this is 0, standard deviation is 1. This is a very beautiful thing. So we can egen any variable called e, and we can standardize it. Let's say we can standardize any expression. Let's say e, and we can supply the mean to be 20, and let's say its variance should be, its standard deviation should be something mean is 20, so it's 5. Summarize d and e. What happens? Control D, control D. You see, mean is 20 and standard deviation. Okay, after this, the standard expression, let us go to total. Control S, std, standardized std, and then let's go to total, and we can use the expression also in that and replace all. And what happens? Control D, we need to drop D and drop E also. Control D. You see what is the total of A into B minus C? Otherwise you can find what is the total of A. Instead, control D. Now let us go to group. Okay. For this, let us create a categorical variable. Let us drop B, C, D. We don't need this anymore. and let us again sort A. Okay, now let us generate a variable called 2 points, right? Eg and egen d equals to cut, let us say A with the 2 groups, 2. So, and we need to label it as well. Right? 0 and 5, okay. And again, egen E equals to cut B, sorry, cut A now into group 3 or even 4, and we want to label it. You see, and what happens? Let's say this group of D is, if 0, this is for male and 5 is for female, and 4 groups in variable E, let's say the place are good, bad, better, best. Then what happens if we group this? See, group. Now we need to create another function. Egen f equals to group, or which variables do we want to group? D and E, and we want to keep their label, so that will be eg to us, right? So it will generate 0 0 0 2 5 5 for this observation, 5 5 if this is male, and if this is good male. This is the way, you see. So thank you very much for your time. Thank you very much. Econometrics Melody.